Okay, this video is a demonstration of what I call disguised quadratics, or reducing other equations to a quadratic. Okay, when I look at a disguised quadratic, I know that a quadratic equation has something squared equal to, we said it always equal to 0 because we want to solve for the x usually. Now this one doesn't have something squared, it has something to the fourth. So the question is, can I rewrite x to the fourth as a square of some kind? And the answer is yes, I can. I can actually say x squared quantity squared. So in other words, is equal to x to the fourth, isn't it? In other words, I can just take whatever that is and then just square it, and it becomes now a quadratic equation. Now what I usually do for this is I use a Greek letter called a mu, or a mu. I like to say mu even though it's mu. And I'll say mu is equal to x squared. And then I square the mu, and if that x squared squared, which is just x to the fourth, if the mu squared is equal to x to the fourth, then I have a disguised quadratic. I call this my mu test. Mu is, like I said, a Greek letter spelled mu. Okay, so let me try that again. What you do for define the mu is you take this middle term, always, no matter what your disguised quadratic looks like. You always take its middle term and you just call it mu. And then you square it, and if you get the quadratic term, or the term in the front, then you have a disguised quadratic. Okay? Play that over a couple times until it kind of sinks in. Now what I'm going to do in my second step is I'm going to rewrite everything using the mu. So what I've got here is mu squared minus 5 mu plus 4 is equal to 0. Okay? Now, this is actually pretty and it's easier to see than this one. This is actually factorable. This basically just says that mu minus 4 and mu minus 1 is equal to 0. That's the factored form of that. That basically just tells me that mu is equal to a positive 4, or mu is equal to a positive 1. Now I'm going to go back and replace what my mu is equal to. Mu is actually just equal to x squared. So let's go ahead and replace mu with x squared. Okay, and from this point on it's fairly easy to solve. The square root of both sides is x is equal to plus or minus 2. On this side you get the square root of x squared is equal to the square root of 1, or x is equal to plus or minus 1. Now this tells me that I've got two answers for x and two answers for y. This tells me, if I wanted to put like a little graph on this, that my graph of my equation is going to be at negative 2 rather, and positive 2, and negative 1, and positive 1. So it's going to look something like this. Okay, now how do I know some of these things? Well, I know that looking at the original equation, my degree is 4, which means that this is going to cross the x-axis a possibility of 4 times. And sure enough, it does do that at negative 2, positive 2, negative 1, positive 1. I also know that this term, the c, or the constant, is where it crosses the y-axis. So 1, 2, 3, 4. So that's where it crosses on the y-axis. So it's going to look probably something like that. Okay? Go through this a couple more times and see if you can understand what I said. I'll try a couple more examples. Good luck to you.